Okay, this is chapter 21, cost, volume, profit analysis. And in this presentation, we're going to be looking at graphical representations of CVP. Okay, so using a cost, volume, profit chart and a profit volume chart, determine the break-even point and sales necessary to achieve a target profit. Like it's easy to actually prepare these charts, but what they're good for is to explain to other people, like if a manager wants to see it. You know, frequently they don't want to look at the formulas and results like that, but a chart says volumes, you know, any kind of picture. So a cost, volume, profit chart, it's also called a break-even chart, okay, graphically shows sales, costs, and the related profit or loss for various levels of units sold. And what's neat about these is that you can manipulate them and see the changes. Okay, now they have several of these pages in here, and I just think it's insane. Maybe I'll print them off and you can see them if you want, but volume is along the horizontal axis, okay? Total sales starts at 0 and goes up, all right? Total cost starts out with fixed costs, and then you add your variable costs on top, and then break even is the intersection between sales and total cost. Okay, so maybe that's the way to look at it. So volume along the horizontal axis, total sales, total cost starts out with, starts out with fixed cost and then adds variable cost. And then break even is the intersection of total sales and cost. Okay? It's an awful lot easier just to look at the chart. All right, this is so much better. Now these are the assumptions with this example. We've got total fixed costs of $100,000. And the unit selling price is 50, there's the variable cost, and here's the unit contribution margin. So let's start out with cost first, okay? Here's my cost. At 0, it starts out at fixed cost. Okay, so even if we don't have any sales at all, my fixed cost is $100,000. Okay, and then for each unit I sell, I get another 20 bucks of contribution margin. And you can just, you know, once you've got that slope, you can draw that line straight out. Okay, those are all my total costs. Now my selling price is a mystery. No, I don't know what it is. Sales are what? Okay, that's 50,000 for, I don't know what the sales were. You know what? I get rid of this. 50,000, duh, it's 50. Sales are $50 a piece. Yeah, $50 selling price. So it's right there. So at 1,000 units, we've got 50,000 in sales. All right, and at 2,000, 100,000, and at 3,000, 150,000, and at 4,000, $200,000 worth of sales, and at 5,000, 250, and then it goes up. All right. Now, what's neat about this is at the point where the total cost and the total sales line intersect, that's your break-even point. Okay, so somebody could really see that. That would be easy to see, and you can even imagine, like, if your costs went up, you know, that intersection line would go out further. So, but it's, you know, it's easy with a computer, with Excel, to run a graph like this really fast. The other nice thing that it illustrates is the operating profit right here. Okay, this is all profit, and then down here, this would be a loss. Okay, so anything less than 5,000 units would be a loss, and anything greater would be profit. Okay, so this is a cost, volume, profit chart, or I mean, it's really more commonly called, let's call it a break-even chart. That's how I've always seen it, for what that's worth. Okay. So the break-even point for this company, okay, is 250,000 of sales, which represents sales of 5,000 units. And just like we said, profit will be earned when the sale levels are to the right of break-even, and loss when it's to the left. Okay, so these are profits, and that's loss. Okay, now let's change it a little bit. Let's assume that he's evaluating a proposal to reduce fixed costs by 20,000. Okay, in this case, then total fixed cost would be $80,000. So now what happens is the total sales line doesn't change, but our total cost line changes. And what changes is that starting point. Okay, so here are our assumptions. And our starting point now for cost is right there at 80,000. Okay, so then I add my what is it? Cost $30 per unit, and our break even changes. Our break even is now reduced to $4,000 or 4,000 units, I'm sorry, or 200,000 in sales. So that's huge. So if you could reduce your fixed costs, it's a big reduction though. That's a 20% reduction. It's not 5%. That's a lot. But you would reduce your break even all the way down to 4,000 units. So you can see though, what would be good about this is to have a good handle on your company and know what the cost function looks like. You know, a picture like this you can really remember. I mean, you'd remember 4,000 units if you saw it like this. Okay? And the other thing is you can do a lot of what if with it. So another approach is the profit volume, which plots only the difference between total sales and total costs. Now, frankly, I've never seen this used in industry. Maybe it's used now. I don't know. I haven't, worked for a while, but I've never seen it. But this allows managers to determine the operating profit or loss for various levels of units sold. So let's see what we've got here. Oh, we got more instructions. So volume is okay. That's along the horizontal axis. Volume in units, just like before. Okay. A point representing maximum operating loss is maximum operating loss is on the left. So we're going to have it like a below zero. Okay. We'll have to look at the graph. A point representing the maximum profit within the relevant range is plotted. And a diagonal profit line is drawn connecting the maximum operating loss with the maximum operating profit. Then we've got a line, okay? And the profit line intersects horizontal zero. It says, okay, let's read that again. The profit line intersects the horizontal zero operating profit line at break even. Okay, so let's take a look at this. Well, these are our assumptions. Okay, we've got sales of 10,000 at 50,000. Variable costs are at 30, contribution margin at 20, so 200,000. Fixed cost is $100,000, so our maximum profit is 100,000. I guess that's the maximum. I guess that's important to understand. The maximum units that could be sold. Okay, the maximum units that could be sold within the relevant range is 10,000 units. So that would be our max. So now we'll take a look. Okay, so notice that the zero is here in the middle, correct? All right, this is zero, and there's our fixed cost. Brings us down at zero. Okay, our fixed cost is all the way down at 100,000 because that's our total fixed cost. Okay, is $100,000. So every time we sell something, we start digging ourselves out of the hole. And here at 5,000 units is our break-even point. Okay. And the most we would make if we sold 100,000 units or 10,000 units would be $100,000. So then you draw a line from 0 to 100,000. This is your operating profit area. Okay, there it is at 60,000 in, is that what we had before? 60,000 in profit. Okay, that's how much we would make. We would have to sell 8,000 units. Let's go back and see what this is supposed to do for you again. Only the difference between total sales and total cost. Allows managers to determine the operating profit. Oh, okay. Can't you do that here? Oh, yeah, maybe not. Well, you'd have to, it would give you sales. So let's go down here. So this, the x-axis is your profit line. Okay, so that's what's different between the two charts. On the other chart, this is sales. This is units of sales in both, but this one is profit. So there you can actually, see what the profit is, so I can see why that would be a good chart. So the break-even point is still 5,000 units, and that's equal to total sales of 250,000. And operating profits will be earned when sales levels are to the right of the break-even point, operating profit area. Okay, and losses would be earned when sales are to the left. Okay, break even, which just makes sense. So here's another example. Now he's looking at a proposal to increase fixed costs by 20,000. So now if fixed costs go up by 20,000, operating profit reduces from 100,000 to 80,000. And the break-even point will increase to 6,000 units of sales. Okay. So the operating loss area will increase while the operating profit area will decrease. So let's take a look, and they talk about here it is. This is the chart. Now I looked at this for a long time and I couldn't see it, but where it is over here. Originally we started out with a loss of $100,000. That's our fixed costs. So at 0 sales, we were $100,000 under. Okay, this is the original chart right here. Now we're going to increase this. It's like, what's different about this picture? It is, we're increasing the fixed cost to 120,000, which brings it way down to here. Okay, and when we're going to have to sell 6,000 units to break even. And you can really see, if you look at it, the operating profit area is much smaller for when our fixed costs are higher. And this is the range that we're looking at right in here. That's the 1,000 units. Before break even was at 5,000 units. With the extra 20,000 in fixed costs, break even is at 6,000 units. Okay, so that's a pretty vivid portrayal. Okay, so with computers, all of this is much easier to do, and managers can vary the assumptions and watch the chart change. And this is what if or sensitivity analysis. And I worked at a bank for about 5 years as a finance officer, and that's all I did. I did a million of these, lots and lots of what if analysis. And if there's one thing you'd want to learn, if you ever end up working in any kind of a business job, make sure that you get some Excel before you go out. And finally, the cost volume profit depends on assumptions. Okay, and the primary assumptions is that sales and costs are straight lines. They seldom are. Okay, but it's an approximation. And within the relevant range, efficiency doesn't change. Okay, the costs can be divided up between what's variable and what's fixed. Okay, that the mix of sales is constant, and that there is no change in inventory quantities during the period. Those are all the assumptions underneath cost volume profit. Okay, so you should be sort of familiar with those. Just understand that there are some constraints on the technique. Okay, gang.